All right, guys, now that you're very good at putting together electron configurations, we can figure out how to use a really well written electron configuration to make a valid Bohr model of an atom. So what I have here is an electron configuration for the element molybdenum. This is element number 42. Its symbol is MO on the periodic table. And the reason I know that is, well, because I did it, and because when you look at this periodic table, which we've done in class, we can see that molybdenum lives right here in this square. This symbol right here under the D4 is molybdenum. And we know that in the D block, things get a little bit strange. We go from the 5s sublevel into the 4d sublevel, and molybdenum sits at 4d4. That is the end of the electron configuration and sort of identifies which atom we're talking about. Okay, so let's use this to put together a Bohr model. I'm going to start with a nucleus here in the center, and since we know that molybdenum is in the the fifth energy level here, even though it's in it's a 4d sublevel element, it's still in the fifth energy level. So we know that there's going to be 5 circles around this thing. 1, 2, 3, 4, and 5. Okay, so let's take a look at our electron configuration and just fill in the electrons into these energy levels. So we start from the left of our electron configuration, and what we're looking for is that first quantum number, that principal quantum number. The big number in front of the letter is what we're looking at, and there it is, it's the 1. And we know that this number here represents the total number of electrons held in that energy level. So we're going to put our 2 electrons here. Okay, that's the only sublevel within the first energy level, so we're done with the first level. Our second energy level is actually both of these guys. We see a 2 here and a 2 here. So we need to add up these superscripts here. 2 and 6 makes 8. Okay, that's good. In our third energy level, you kind of have to be careful here because the third energy level is these 2, and it's also going to include this one, but not yet. We want to fill our lowest orbitals first, our lowest energy orbitals first, and 4s is going to actually fill before 3d. So the first thing we're going to do for our third energy level is add our initial 8 electrons. Okay, there's going to end up being more in there, but the next thing we have to do is put 2 electrons here in the 4th energy level, right? So now that we've done that, we can go ahead and backfill our next 10 electrons into the 3rd energy level. 2, 4, 6, 8, and 10, okay? So now we have all 18 of the electrons that would max out that 3rd energy level. We've just added them sort of part by part. So we've started to add our 4th energy level already. Now the remaining electrons in the 4th energy level come from this and from this. So remember, in an electron configuration, your sublevels can be sort of divided by other other parts of the electron configuration. So you've really got to look for that big number there. So after 3d, we're going to fill 6 more electrons into the 3rd energy level. 2, 4, 6. Okay. Then we're going to start filling the 5th energy level with our 2 electrons here. And then finally, we're going to backfill the remaining electrons into the 4th energy level up to 4. Okay, so we're going to put 4 more electrons into the 4th energy level. And that there is a valid Bohr model of a molybdenum atom. And that's how you do it. You just have to sort of think about this big number at the front being the energy level, and then this is the number of electrons that are going to be present in that level. And those things can be spread out. In the first two energy levels. They're not, but then they begin to sort of space out in this funny way here. So anyway, I hope that helps with Bohr model diagrams.